In this lesson, we're going to use the properties of logarithms to rewrite expressions. Inverse properties of logarithms. For any base such that b is greater than 0 and b is not equal to 1, log base b of b to the x is equal to x, and b raised to the log base b of x is equal to x, for x is greater than 0. Now, this is nothing more than what we call the fundamental identity of inverses. Recall you've learned in previous lesson that when you have a function and its inverse and you find the composite of that, in other words, plug one into the other, that it is going to equal x. So you can think of b to the x as being the function and log base b of x as its inverse. So when you plug one into the other, it's going to equal x. So if we take the first function here of b to the x and plug the second function into it, it will equal x by the definition of the fundamental inverse property. Same thing is if I take the inverse function, which is log base b of x, remove the x and replace it with b to the x, it also equals x. So what does that mean in terms of an actual problem? Well, let's solve one. So here we have 3 raised to the log base 3 of 12. Notice here that this base is the same as the base within the exponent, within the log. That goes with this property here, that the base is the same as the base in the exponent, that it is going to equal whatever is in the back of the base. In other words, log base b of x is going to equal x. In this case, it's log base 3 of 12, so it's going to equal 12 in that case. Here we have log base 7 of 7 to the third power. That goes with this inverse property here, where when you have the base is the same, the base within the log is the same as the answer, that is going to equal your exponent there. So in this case, the base here is the same as my answer here, so it's going to equal my exponent. So then log base 7 of 7 to the third power is going to equal 3. Let's do some more practice with that. Here's another property you need to be familiar with. For any base such that b is greater than 0 and b is not equal to 1, log base b of b is going to equal 1. So if you have a log where its base is the same as the answer, then it's going to equal 1. The other scenario is if you have log base b of 1 equals 0. Anytime your answer equals 1 here, that it's going to equal 0 because 0 is the only power that you can raise a number to and get an answer of 1. So anytime you have log base b of 1, it is always going to equal 0. Okay, so let's follow this example here. Here, log base 5 of 1. Again, whenever our answer is equals to 1, it can only be one number that it can be raised to, and that number is 0. So this is going to equal 0. Okay, one way you can solve these two is you can set them equal to x and then solve. So this will be 5 to the x equals 1. So then x is 0 because 5 raised to the 0 power equals 1. Okay? Here again, if you like, you can set it equal to x and solve it, but you can just apply the basic property of logarithm, which states that when the base and the answer is the same, that it's going to equal 1. So I already know this equals 1, but here's another way you can do it, is set it equal to x and then go 3 to the x equals 3. So in other words, what number will I have to raise 3 to in order to get 3? And that would be 1. And there you have it, basic properties of logarithms.